Hi, everyone. My name is Dan Lorenc. I'm a software engineer at Google on the open source security team. I'm going to be talking about open source supply chain security today. If you've heard of all of these different supply chain attacks in the news lately, I'm going to be explaining what they are and how they affect open source software. So I'll start out by introducing myself a little bit. I've been at Google for about 9 years now, and I've had the privilege of working in open source software for about the last 6 years out of those nine. While working in that space, I've done a bunch of things in the container and Kubernetes area, and that's what got me started worrying about open source security, specifically supply chain security. So I started a couple different open source projects, and I've been doing a bunch of work over the last few years to try to improve the situation. And luckily, sometime in the last 6 months or so, it seems like everyone else has started paying attention to supply chain security as well, especially in open source. So that's probably why we're talking about this here today. If you're interested in reading any more of this stuff or seeing any of the other projects I work on and trying to make this stuff better, I tweet on Twitter, and there's my handle. It's Lorenc_Dan. So let's jump into today's topic. I'm going to start out by describing what I think are the two main problems with open source software, open source security, and supply chains today. I'm going to cover what you, as an individual or a company, can do about them to protect yourselves today, and then what I think we as an industry need to do about them going forward. So I'm going to start out with the two problems, like I said. The two problems with open source, with the security of open source software, is that number one, open source software is open source. That means anybody can see it, anybody can contribute to it. This has a bunch of benefits, but it also has some downsides that I'll cover in a bit. And then the second problem is that just like all software, open source software is software. All software has bugs, whether I write it, whether you write it, or whether a group of people that you've never met writes it in an open source community. So these are kind of the two problems. They're right there in the name. It's open source and it's software. You have to address these two problems differently because they are different problems. So let's jump into those. Finally, when you start looking at supply chains too for open source software, there are threats everywhere. So we've got these two problems: the fact that it's open source and that it's software, and then it's a very complicated supply chain here. So at every single one of these points, every time something gets handed off from a developer to a source code repository to a build system, these are different places that threats can come in. So we've got to be looking at the problems with open source and software at every single one of those levels. So let's start out with the first problem. What do we do because open source software is open source? Like I said, it's not a problem that open source software is open source. There are just a lot of different things we have to fix because of it. Open source software is free. It's one of the biggest reasons people use it. But sometimes just because it's free doesn't mean that it's free to you. Sometimes free is not worth it. Sometimes the problems that it comes with actually cause more problems than it's worth. Second, anyone can contribute. Well, anybody that spent time on the internet knows that not everyone on the internet is nice. There are people out there trying to insert bugs. There are people out there trying to find problems in open source supply chains and attack it. So just because lots of people can contribute and there might be lots of eyeballs on something doesn't mean that the source code is secure. It's really easy to use open source. This problem has crept up because sometimes it's too easy to use. If you're at a company, you might not even know all the open source you're using. This comic here on the right kind of depicts that. All the modern infrastructure that we see is kind of up here at the top. These are all the things you think you're using. You might not have any idea all the open source that's powering those things on top that you're looking at. And a lot of it ends up being maintained by a single person, thanklessly, that you don't even know, and you might not even realize you're using this software. So because it's free and it's so easy to use, you can get yourself into some tricky situations here. Finally, there's this belief that open source is transparent because you can see the source code. And this is true, except how many people are actually looking at the source code for all the open source they're using? Most people are getting open source through package managers, downloading binaries. Very few people are actually looking at all the source code and building it all themselves. So in reality, the source code is transparent, but the way a lot of people are consuming open source makes it opaque. So let me cover some examples here of attacks at every single one of these levels that we just talked about. This is a brief history just over the last year or so, and there are probably a whole bunch more attacks that have happened since I made this presentation that haven't even been added here yet. It seems like there are new ones almost every single week that we forget to add. But I'll cover a couple of these and just kind of explain how they work and some of the problems they've caused. One of the scariest ones, going back to April of last year, and this is a recurring problem, is typo squatting. So this example here, there were 700 packages taken down for typo squatting on Ruby gems. This happens every couple months. Somebody does a research program and finds a whole bunch of packages doing typo squatting uh, that are malicious, and they get taken down each time. Every 3 or 4 months, you see this across Ruby gems, across PyPy, NPM, all the different package managers. So typo squatting is a really tough type of attack to handle because it's so tricky. It's a form of social engineering. This is where somebody will upload packages with names that are designed to sound official and trick people into downloading these instead of a real one. They're not always typos. We see this with Google packages sometimes, where we have a package that might be named like Google Cloud Storage or something like this, for example. And an attacker will upload something maybe that uses an acronym or uses some Unicode characters instead of the O's in Google. So you might see like GCP Cloud Storage or something silly like that that's been uploaded by somebody else. So it's impossible for us to think of all the different permutations and Unicode characters that people can use to try to trick people. So you have to be really careful in making sure that you're installing things only by their actual official names. You see this also happened in September of last year on NPM. And the malware there was actually used to steal people's PII from a database. So stuff can be pretty serious. NPM, the node package manager, sees a lot of attacks in general. It's also one of the most commonly used ones. So it's hard to tell if it's a problem with NPM or if it's just directly related to the usage. We've seen some other scary attacks here in NPM. Because it's so easy to install stuff and you might not know that you're pulling it in, these packages can do a whole bunch of bad things. So one of the other examples here is setting up reverse shells. Open source software is pretty easy to install inside of your CI system, so people do that constantly. And this program this was the one in October of last year I'm referring to, set up a whole bunch of reverse shells, which give an attacker direct access to your CI system during a build. And people were able to go in and steal secrets from the build systems that way. Another really scary one here, because open source is free and maintainers aren't getting paid, is the Great Suspender extension compromise. So this was a Chrome extension called the Great Suspender. It was one of the most commonly used ones in the Chrome store. And what it did was, what it was designed to do anyway, was suspend tabs that you weren't using for all the people that have thousands of tabs going on their computers. So this would suspend them and try to save battery life on your laptop. Somebody built this by themselves and maintained it for years, and eventually sold the rights to this extension to someone else. So it was open source on GitHub, but after it was sold, the buyer, took it down off of GitHub and started building their own version and publishing it to the store, adding some malicious code. So it wasn't present in the GitHub repository. It was being present and inserted into the build system. So that way the binary published on the Chrome store had some of this malicious code. It was eventually taken down when people discovered it. This is a case of open source being free, being hard to make money off of, which can sometimes lead to bad incentives and people taking advantage. There have been a bunch more attacks in the last couple months. There was a paper from the University of Minnesota that's gotten a ton of attention lately. What they were trying to prove is that it was possible to insert bad commits into the Linux kernel. So they took commits that they knew had bugs and tried to get them reviewed and inserted. This sort of backfired and led to a whole bunch of bad publicity and everything like that. But it is clear that this type of thing can happen, especially in large projects. And then a whole bunch of other scary ones here that I'll go through quickly. Microsoft's VS Code, popular text editor. This attack was actually reported by a researcher, so it wasn't something malicious, but this could have been one of the scariest ones in recent memory if it was bad. But an attacker was able to use some misconfiguration in the VS Code GitHub repository to get commit rights and to merge code into a release branch of VS Code that would have made it out to people's installations. If an IDE or something like that gets compromised that developers are running all over, then you would have to kind of lose trust in all of the things that IDE has built. That would have cascaded very quickly, but luckily it was a researcher who reported this rather than someone malicious. More typo squatting, and then finally, one of the biggest ones of this year, it was the codecov.io attack. So codecov.io is a code coverage service that provides free coverage reporting over time to open source projects. Unfortunately, the way that a lot of people use and integrate codecov into their CI systems is with a bash script that they use curl to grab from codecov.io/bash website. CodeCov unfortunately leaked some of their credentials in their own CI system, and an attacker was able to find those and serve malicious scripts that stole secret environment variables from CI systems. CI systems are known for having quite a few secrets in them, especially things to publish other artifacts. So CodeCov had to notify all of their users, and anybody with CodeCov in their CI systems should have had to do a scrub and make sure that all secrets in there had been rotated, and anything that those secrets had access to have been audited. Um, this is not a new thing. Supply chain attacks have been happening for a while, but they are accelerating, and they're going to get bigger and worse over time unless we do something about it. So now that I've hopefully scared you, but not too much, what are some things that you can do to protect yourself when you're using open source software? A lot of this is obvious, but it is hard. So you kind of just have to do the best you can. Step one is know what you use. This sounds obvious, but it's not always that easy. If you're a developer and you haven't looked through your vendor tree or your dependency configuration file for a while, some stuff might have crept in there that you don't even know. If you're installing a couple dependencies, those dependencies have a couple dependencies, and this kind of blows up exponentially pretty fast. If you install a couple things, you might end up with 500 in there. You might trust the dependencies that you're using, but unless you trust the full transitive tree of all of their dependencies, you can end up out of control. So this is really hard, especially when you start building artifacts and publishing them and combining those artifacts into other artifacts. It gets pretty hard to keep track too. If you're practicing something like continuous delivery, you might actually have a couple different versions running in production of your own application at a time. If your application dependencies are changing, then you can see that the combinatorics start to get pretty tricky. And you might end up with a whole bunch of different versions of your application with different versions of dependencies. When a vulnerability gets reported, either something unintentional or something malicious, if you can't quickly figure out exactly what you're running in production, you can get into trouble. So step one, know what you use and be able to look that information up as quickly as you can. Once you've done this, you're actually in a pretty good spot. A lot of people aren't able to answer those questions, especially not quickly. So step two here, once you know what you use, to take it to the next level is be able to control it. Be in control when new dependencies are added. Continuously audit them, continuously compare the old dependencies you're using to vulnerability databases and look for old bugs. Implementing governance and control about all of your dependencies, whether they're internal or open source, is really one of the best ways to protect yourself so things can't slip in without knowing about them. And this applies both to your code as well as your build system. When you're inserting new tools and services and things like this in your build system, you really want to be reviewing those and treating them just as seriously as the rest of your production system. Your build system is what gates the code that you're building into production. So the security there of your build system needs to be at least as high as your production environment. And then finally, if you really want to take it to the next level, is stop consuming binary packages. You don't know what's in them, and in most places, it's pretty hard to verify any of this stuff. Very few projects are doing things like reproducible or verifiable builds. So you're really trusting a third party to compile things correctly, to not insert any malware, and to secure their own build systems. So if you really want to take full advantage of open source and the transparency and the visibility, you want to build what you use directly. This is really, really hard. So you don't need to do it all or nothing. You can take some of the dependencies you have and build those, some of the most critical ones. The point of open source is to be able to change it and compile it and build it yourself anyway. So this also sets you up to take advantage of a lot of that stuff. Half of the battle here really is knowing that you can build it if you ever have to, if there's ever a vulnerability you find that you can't get fixed upstream, or if there's ever a change you need to make that you can't get upstreamed. Being able to add that patch locally, build it, and get it out to production quickly shows that you're in control and that you can react to stuff quickly. So, as an industry, what should we all do though? These things are mostly about protecting yourself, not really improving things for everyone else on that last slide, which is kind of against the whole point of open source. So there are a lot of things that we can work on together as an industry to make this easier, to make it so everyone doesn't have to worry as much. I think the first one is to make it all easy. Security is not a priority for the average open source developer, or the average software developer in general. Security is an afterthought, unfortunately. Um, so by making it as easy as possible and as automatic as possible, we can make people actually do the right thing by default. This means we need to build new tooling, data, and use all the crypto that's out there to start securing supply chains that people aren't doing today. Um, there are update frameworks that are secure that we need to be using instead of curl pipe to bash. But curl pipe to bash is so easy and people keep doing it. We need to make these secure mechanisms as easy or easier if we want people to actually start adopting them. And you want to require this for your own company, right? Lead by example. Back to that first slide. If you start requiring your developers to only use things that are built responsibly and implement these security best practices, then you can actually spend time helping upstream to implement these so that you can use it. This is definitely going to be easier than writing things yourself. Nobody can stop using open source completely today. We're way past that time. And then finally, normalize supporting maintainers. There are a lot of models here. You can try some. You can fund maintainers, you can help them, you can send patches, you can sponsor a project, you can get your logo on the page. There's a lot you can do here. And then finally, interoperability of metadata, right? Once we get people to start producing all of this metadata of their build systems, what commits they're using, what build tools they use and everything, we want to make sure we can exchange this across the industry. The Continuous Delivery Foundation, which Google is a sponsor of, has a working group that's focused solely on interoperability of supply chain metadata. So some of this work is amazing, and some of the most popular build tools out there are adopting some of these new formats so we can exchange all of this. So that covers the problem with open source, the open source portion of open source software. And that's really mostly relevant to supply chain attacks, like I showed on that first slide. The second problem, though, and why a lot of people kind of throw up their hands and say, why should we even bother fixing the supply chains, is that open source software is software. It's full of bugs, it's full of CVEs that can be exploited. And some of those bugs might be malicious, but for the most part, most of them are not. They were inserted by accident, but people can still take advantage of them. So what do we do about that problem? I'll start with showing some examples here of some pretty scary ones that have happened. And all these were not malicious bugs. They were just things that were put in by accident that people found later and took advantage of, or didn't if they were reported responsibly by a researcher. A lot of these famous CVs get cool logos like this and websites set up, which helps them get popularity, but not all of them do. These are just some of the ones you might have heard of. Heartbleed was one of the biggest open source vulnerabilities that was found, and really raised people's awareness of this whole area and the whole problem of the open source ecosystem not having the support it needs. Heartbleed was a bug in OpenSSL, one of the most commonly used libraries for securing internet traffic. And it had been in the project for years, and it was possible to exploit this to steal secret credentials and inspect traffic that people thought was secure. It's a pretty simple fix, but it had been present for years, and we don't really know the impact of it. Apache struts. This is a slightly more boring one. This is a serialization library, which are always known to have problems because they're processing untrusted inputs. But one of these led to a remote code execution flaw. This happens all the time. It's no big deal, except the problem here was that people did not update their Apache struts correctly. And this led to the famous Equifax breach, where they didn't update their Apache struts, and an attacker was able to steal a whole bunch of data because of this remote execution flaw. Shell shock is another scary one. These bugs can happen in even innocuous programs like your bash shell. This is an issue where a certain environment variable set up in bash, one of the most common interpreters out there on most systems, could be exploited remotely. So just by having a bash interpreter present in your program, even if you don't think you're using it, was able to lead to a whole bunch of remote code execution. There are countless more of these, but these are the type of bugs I'm referring to in this section. So even if you are building things from source and knowing what you use, you still have to worry about these kind of 0 days that are found and reported. Yeah, this is a kind of comparison between the bugs that start to get attention and what people actually have to do about them. What most people worry about, what you see, is these 0 days with the logos that I just covered on the last slide. Everyone wants to protect their systems from bugs they don't know about yet. These are the scariest ones that keep you up at night because they're kind of unknown unknowns. They're found by research firms. There's usually huge bug bounties involved. And there's a lot of research that goes into these. To deal with these correctly, you probably want to have a plan in place to deal with them. Figure out what you would do if a really scary 0 day is found in all of your systems. And this can be tricky if you're deploying software into customer environments all over the world, and it takes you days or weeks or months to convince everyone to update. You want to worry a little bit more about this and have emergency playbooks in place for how to do updates faster if you need to roll out a patch. But other than that, you can't really control it. So don't worry too much about the ones you don't know about. The really scary ones here, the ones I worry the most about, are the known bugs. These are the old ones that have been sitting in code forever. This is the Apache struts. And if you have a lot of environments set up and systems running all over, it's easy to lose track and not know that you're running a server under somebody's desk that's exposed to the network, exposed to the internet, with a version of software you forgot to update. Just because you forgot about it doesn't mean an attacker won't find it. Right? These things are easy to find from the outside. So what you got to do is just keep updating things. Pay attention. Don't get lazy. Don't get sloppy. It's not exciting, but every organization needs to do this. You need to track what's running where, and you need to update it constantly. If you update frequently, the updates get easier, and it's kind of a self-rewarding cycle. Smaller updates or easier updates, which you can do more frequently, which make it easier to keep updating even more frequently. There's some pitfalls here, though. This is usually grungy, kind of more boring work that isn't rewarded, so nobody wants to do it. The easiest thing to do is reward this work at your company. Update, update, update. Automate this, make it as easy as possible, monitor it and track it. These are the embarrassing ones to get caught by too, because you have no real excuse. 0 day is something that hits the entire industry, everybody using a particular piece of open source software, getting hit by a 4-year-old vulnerability in something that's been patched for 4 years as well. It's much harder to come up with an excuse for that one. So don't get caught by these. These are what everybody should be worrying about. So, what can we do as an industry about this? I think one of the best things we can do to start fixing all the unknown bugs in all the software that we're using is to normalize working upstream. And I think it's probably about a factor of 100 to 1 if I had to guess, in companies using a package to companies that have ever contributed a patch to that package, maybe even more than that. Make that easier for your developers. Make it easier to send fixes. This has a ton of benefits, both to the open source project, the open source ecosystem, and to your company. If you're using, making a bet on a huge piece of infrastructure software, it's awesome to know whether or not you can get a minor bug fix upstreamed. You'll learn the development flow. You'll learn how the project works. You'll learn how they take security. You'll learn how they treat small bug fixes like this from important users. If you try this once on something small that you find, it'll give you confidence going forward. If you can't get something in, or nobody's responsive, or nobody's even there to review the code, that's maybe a signal you should take to look for a different package if something's been abandoned. Giving back and fixing bugs upstream also builds important bridges, and it helps improve the public good. There's a great blog post about this from Julia Evans when her company was evaluating using Kubernetes. She actually went and found some bugs and tried to fix them just to learn what the development process was like, to learn the architecture of the system, and it worked out great. So in summary, to wrap this up, open source software is just software. There's this common misperception that just because you didn't write something, or because something is published on GitHub and has a whole bunch of stars, that it's been well reviewed, it's been audited, it's secure, and people have found all the bugs. That's just not true. I've written tons of open source software, tons of stars, and there's bugs all over it. All software has bugs, not just the stuff you write or your company writes. And then supply chains are tricky. Supply chains are scary, and all the components of your supply chain need to be treated as critical production systems, because that's what they are. They gate what goes into your production environment, and so failing to protect these is like leaving the door wide open. Open source is great. I don't want to scare people away from using it, but some of the aspects that make open source great do make certain classes of attacks easier. These aren't things that are unsolvable. We just need to actually take them seriously and solve them. We can do this by working together as an industry and by supporting open source communities. It's easy, it's much easier than you think, and it's worth it. So I hope some of this scared you a little bit, enough to look into your own supply chains, but not too much. We can fix this together, and we're working on that here at Google and with a whole bunch of other companies. Here are a bunch of links and some of the projects that my team is contributing to help out here. I won't read all of these. We can find them later. But we're trying to make it easier to sign software in the SigStore project. We're trying to make supply chains hardened automatically in Tecton CD, finding bugs with OSS fuzz, and a whole bunch of other things. So thanks for listening today, and that's all.